Welcome to Economics Trainer. This video was made to help you strengthen your skills in microeconomics. Here we have a sample question, care of brighttutoring.ca. It's the kind of question you'd expect to see on a test in a second-year microeconomics class. Let's work through it together. So here's the question. Suppose we have a consumer with a utility function with a Cobb-Douglas form where the utility equals x to the 0.1 times y to the 0.9, and that gives them the marginal utilities of MUX equals 0.1 times x to the negative 0.9 times y to the 0.9, and marginal utility of y equal to 0.9 times x to the 0.1 times y to the negative 0.1. The consumer has $100 to spend on purchases on goods X and Y. Now what we have to do is figure out what their optimal bundle will be in terms of how many goods they're going to consume in terms of X and Y when the price of X is $2 and $9 for Y. And then the price of X is going to increase up to $5 and the price of Y will stay the same. Then once we have that change in the price of X, we can use that and these two questions here to map out the consumer's inverted linear demand curve for X in the last question. So let's start off here at the beginning and start finding these optimal bundles. So here we have all the information given. Let's start off by drawing it out here and say, okay, for optimal bundles, we have our budget constraint to start. And we can see for the good X to start off, it has 100 over 2 as a starting point here, which is their real income. And then up here, this is going to be, let's see, 100 divided by 9 for Y. And then when the price of X changes here, it's going to increase up to 5. That changes the amount that they can consume. And the budget constraint is going to pivot in here. And this is going to go down to 100 divided by 5, which is going to be 20. So what we have to figure out is how that's going to change their optimal bundles between these 2 points here. So let's start off by finding the first point here, point A. So let's see here, so for this one here, we can just use the tangency condition. So we do MUX over MUY for the slope of the difference curve, and that'll be equal to the slope of the budget constraint, PX over PY. So let's plug this in for the first point here. Here we have the marginal utility equations up here. So let's see, MUX is 0.1, X to the negative 0.9, Y to the 0.9, and then we write the marginal utility for Y equation on the bottom here. And then over on the right-hand side, we have to use the original prices. So here we have P of X is 2, and the price of Y is 9. So let's see if we can solve it out pretty easily if everything's lined up vertically. So here we have just 1 over 9 with the decimal point, so that's going to be over 9. For X, let's see, we got to subtract the exponents. So we have negative 0.9 minus 0.1, so that'll be negative 1. So we have X on the bottom. Then for Y, let's see, 0.9 minus 0.1, so I'll go positive, and that'll just be Y to the 1. So we'll have Y on the top. And the right-hand side will keep the same. And we can see here, well, the 9s will cancel on each side, and we can move the X over, so what we get is Y equals 2 times X. So that's your tangency condition for part A for the first point. And then to find the second point here, we have to use the budget constraint. So say, okay, the budget constraint is income equals spending. So I equals PXX plus PYY. So we have income 100. The price of X in the first case is 2. Price of Y is 9. And then here, let's combine these two equations together and say, okay, wherever we have a Y, we can just plug in 2X. So we say, okay, now we have 100 equals 2X plus 9 times Y, which is equal to 2X now. And let's see, okay, we have 100 equals 2X plus 2 times 9, which is 18, so that'll be 20X. So the X star at the first point A is going to be equal 5. And then to figure out Y, we can just plug it in here. So for Y, that's going to be 2 times 5, so that's 10. So that's going to be this point right here. So we're going to have 5, and we're going to have 10. So that's the first part of the question here. So we say, okay, 5 and 10 for the first point. Now to find the second point, all we have to do is just change the price of X and repeat the process. So for this point down here, we're trying to find this one. It's the same process, so we say, okay, we're going to have the same equations here. So everything is the same on the left-hand side. So you can see the left-hand side, that's just going to become Y over 9X. And then here on the right-hand side, instead of having 2 over 9, we're going to have 5 over 9. So you can see here for this one here, this just becomes, the 9's disappear, and we get Y equals 5X. So that's going to be your tangency condition for B for this point here. And then for the budget constraint, we do the same thing. We just take this equation over here and say, okay, for the budget constraint, it's income equals spending. So let's see, we have 100 equals PX, but that's now 5. And then plus 9Y, and then Y is going to be 5X. So let's plug it in here as we go. And then see what do we have. We have 5X plus 45X, so that's going to be 50X equals 100. So here we have X star B is going to be 100 divided by 50, which is 2. So that's going to be this point here. And then to find the Y at this point, we go back up to this equation here. We say, okay, Y is 5 times X. So of course it stays the same at 10 because its price didn't change. So this point here is also going to be the same point there. So that's how we solve the second part. So now we have 2 and 10. And what that gives us now is we have 2 points on the demand curve for X here. We're trying to find this linear demand curve. We say, okay, at a price of 2, it's going to be 5. So let's write it out here. We say, okay, for our demand curve, we have point A and point B. And then we have the price of X and the X star. So we can graph it out over here. We say, okay, at the first one, we had a price of 2, and the X star was 5. So let's see, okay, so here we have 2 and 5. What's your point there? And then the other one was 5 for the price, and we got an X of 2. So let's put that up here. So there's point B. So what we have to do here is to find the demand curve. We can just connect the dots. with a straight line, and we can figure out what that is here. So we use the equation of the line here. We say, okay, y equals mx plus b as the general form. So here, in terms of our axis, we're going to have px equals mx plus b. And then we just have to figure out our slope here. So our slope is the rise over the run. So y2 minus y1. So here we're going to have px2, which is 5, minus px1, which is 2, over x2, which is the second one here. So it'll be 2 minus 5 for x1. So what do we get here? We get 3 over negative 3. So it's going to be negative 1. And then we use that and a point to figure out b. So we say, okay, now that we know the m value, we can go back to this equation and say, okay, let's just plug it in for a point here. Or let's use the first point here and say, okay, well, this got to be true at that point. So the px is 2. We know the m is now negative 1. And then at that point, the x is 5. And we can use that to figure out the intercept value b. So we see, okay, negative 5. So here we're going to have b equals 7. So using that information, we can now figure out our demand curve. Put all that together, we're going to have px equals b, which is 7, and then minus our x demand. So up here in the graph, this point up here is going to be 7, and then we're going to have a slope of negative 1. So back here, our slope, negative 1, and the choke price is 7. And that's how you do that question. This video is brought to you by people who like, share, and subscribe to this channel. You can also support my work by buying me a coffee.